All right. I did record like a video, but I don't know where it went. It was like an hour and a half or something. It was me doing GreenBook, but I don't know if I deleted it, but it's can't find it. Continuing on, I'm just doing GreenBook problems, starting from the beginning, and yeah, like hopefully I hopefully I do like. Okay, wait, hold on. I'm on like page 15. Uh, Damn, hold on. I'm trying to get through like all of these hopefully. So like this is what 32. Yeah, in this one session, I hope I complete this like brain teaser thing because I just don't like it that much. We're gonna see though. Here's enough yapping. I'm gonna get to this problem. Suppose that you are blindfolded in a room and are told that there are 1,000 coins on the floor. 980 of the coins have tails up, and the other 20 have heads up. Can you separate the coins into two piles so to guarantee both piles have equal number of heads? Assume that you cannot tell coin side by touching it. Okay. All right. Uh, can I guarantee it? Uh, and I can't tell. This. Oh, I'm allowed to turn over any number of coins. Okay. So both piles have an equal number of heads. Okay. What if like okay, instead of 1,000 coins, let me make it 100 coins, where it's 92 and two. I think that makes it more simple. Um, yeah, let me make it like, or actually, let me make it like 10 coins. 4, 5, 6, 7, 8, 9, 10. And let me make it so that there are 10 coins and there are two that are. I don't know if the ratio of like 2 to 100 actually matters, or 1 to 50, but I'm going to be doing 2 to 10 to see if that like changes anything. Let's say two of these are heads. Um, I was thinking, so like I divide it into like 10 over 2, or I'm just doing it in terms of like fractions, so in that case it would be 1,000 over 20, but I split it into two piles of 5, right? Or I could do 5 piles of 2, I don't know. And I don't know why I'm doing 2. I think 2 because 2 heads, but we'll see. Now let's say I have, let's say I do like 2 piles of 5, right? There are two cases here. So one case being that one of these piles have both of them, or the other case where like both of these piles have one each. Now I need equal number of heads, right? Now in either case, let's say like let's assume the case where both piles have two, right? Sorry, one pile has two. Let's say this is the pile that has both the heads. Um, What would happen if I just keep like flipping alternate coins? Like what would happen? Um, or yeah, let me actually take the 10, right? Let me just flip alternate one. So I flip this one, I flip this one, then I flip this one, then I flip this one, then I flip this one. Okay, wait, I'm making this look chopped, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say the two are like back to back, right? Let's say it's like this and like this. Let's say I flip this one, this one, this one, this one, and this one. I would end up with 1, 2, 3, 4, 5 X's and uh, 5 tails, right? Yeah. Because number of tails will be this, 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 and this. But let's say they were back to back. Yeah, so in any case of back to back, I think let's push this one forward. Same thing, I think. Yeah, I don't think that changes anything. Yeah, let's say they're like one apart exactly, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's 10. I don't know if I overcount. Yeah, no. Let's say they're one apart like this. Start again. Flip every alternate. So this gets flipped, this gets flipped, this gets flipped, this gets flipped, this gets flipped. So 1, 2, 3. So there's only 3 heads now, and five tails, right? Let's say I then split the two. Let's say I take my 3 heads, and then let me take the 5 tails, and then let me again do the flipping strat. So I flip every alternate one. And let's say here also I flip every alternate one, right? So then I get 3 heads, 5 heads, and oh wait, hold on. Wait, actually, if I just do it this way and I just flip it once, oh wait, I could do that. But how would I know? So I can take either piles. Interesting. So I am blind, so I don't know which whether the pile that I'm taking has the heads or not. I just won't be able to tell. Okay. This does require some thinking, which I don't feel like doing. I just want to do some probability, man. I don't want to do any of this. And let me chew a piece of gum. Like, all right. Okay, now, okay, maybe just do the same thing for 1,000 coins. Let me just do it directly, right? Imagine 1,000 coins. Obviously, I'm not gonna draw everyone out. Let's say worst case scenario of like you flip every like alternate one, but the alternate one happen to all be X's. You know, so you get every alternate one should mean that you flip over. So first of all, you take aside any alternate piece, right, and then flip over every single one of them. In that case, out of the 500 coins, 20 coins are like heads already, so you flip them over to tails. So that becomes what's it called? What does that become? Oh my god, I'm actually breaking. Yeah, okay. I don't know why I thought so much. So 480 heads or 480. I'll just do 0. I don't know why I'm doing 0 and x, but whatever. And 20x, that becomes switched. So then it becomes 480 x and 20 of these. And in the other pile, I just have 500 zeros or tails. Is there a way to keep flipping these so that everything ends up the same? You know what I mean? Like, oh wait, what if I take like You know what, let me take like a different example, like, because I also don't want to make it too general and try to like come up with a solution that only makes sense if in this scenario. Say I expect, I'll just do the expected version. So I expect to get like 490 zeros, or in this case I'll have 490 x's and 10 zeros. And in this case I'm gonna have I'm just gonna keep this the same, so I'm gonna have 10 x's because the 10 stay the same, and the remaining 490 are zeros. Now it's never going to be this is never going to be the case, right? In this case I'll have 0 x's. But like, and I just have these two groups. I don't know. I feel like maybe if I like break my head at this for like an hour I might get it, but like, I don't know. Let's say we separate the 1,000 coins into two piles with n coins in one pile, 1,000 minus n. If there are m coins in the first pile with heads up, there are 20 minus m coins in the other one, right? Yeah. We also know that there are n minus m coins in the first pile with tails up. We clearly cannot guarantee that m equals 10 by simply adjusting n. What other options do we have? We can turn over coins if we want to. Since we have no way of knowing which, we won't guarantee it, yeah. However, if we flip all the coins in the first pile, all heads become tails, and all tails become heads. As a result, it will have n minus m heads and m tails. So to start, we need to make the number of tails in the original first pile equal to the number of heads in the second pile. In other words, we make n minus m equals 20 minus m. N equals 20 makes the equation hold. So if we take 20 coins at random and turn them all over, the number of heads among these interesting. Actually, does that actually work? Yeah, I guess that works. Oh, that's actually insane. Yeah, that's pretty good. Yeah, that's pretty good. Because you're gonna have 20 in the pile anyways, and let's say you divide it into this group and this group. Let's say there are m of these, let's say m heads are here, 20 minus m heads are here. But that also means 20 minus m tails are here, and you can always switch them. So, yeah, that's pretty good. That also feel pretty stupid for not getting that. Okay. Okay. You were given 3 bags of fruit. One has apples in it, one has oranges in it, and one has a mix of apples and oranges in it. Okay. Each bag has a label on it. Unfortunately, your manager tells you that all bags are mislabeled. Develop a strategy to identify the bags by taking out the minimum number of fruits. Okay, so there is definitely an answer for this. Okay. There's definitely like, all bags have to be mislabeled. Okay. So let's say I have I have mislabeled bags, right? And that's the whole point. Let's say out of bag 1, I get an apple. Now I definitely know it's not the orange one. So I definitely know it's not the orange one. So the other 2 have to be the orange one. Now, and then let's say I open take out a second one, or from the second one. If it turns out to be orange, it could be the orange one or the apple one. So I know this one's not the apple one, and I know this one's not the orange one. But either of these could be the apple or orange one. the third bag, let's say the third bag is also orange, let's say. Now either of these can be orange, but I know this one's not the apple bag. This one's not the apple bag. So this one's definitely the apple bag. Well, which one's the apple and orange one? They're all mislabeled. So this one would have been labeled, let's say, apples, oranges. This one, oh, okay. If this one, oh, okay, wait. Then that's simple then. Okay, wait, hold on. I didn't think of the labeling as well. So let's say this one's apple, this one's orange, and let's say this one's also orange, right? This one would be mislabeled. So in the case that this one's labeled oranges, right? It could be labeled oranges or it could be labeled mix, right? Now, if it's incorrectly labeled mix and I pick up an apple, then I know this is the apple bag, right? Then one of these are going to be labeled the apple bag, and then one of them is going to be labeled the mix bag. One of them is going to be labeled the orange bag. So whichever one is the orange bag labeled is not the orange bag. Do I even need to pull out the third one at that point? Hold on, let me see. So let's say I pull out an apple. The two choices are either it's labeled mislabeled by orange or mislabeled by mix. In the case that it's mislabeled by orange, I know that it's either the mix or the pure apple bag. I don't know yet. Right, and then let's say the second bag I pull out. Let me analyze two cases here. Let's say I pull out an apple, right? Now if this one's mislabeled orange, this one's either mislabeled apple or it's mislabeled mix. If it's mislabeled apple, then we know this one. Then we already know it, so we're straight. If we know it's mislabeled a mix, then we know it has to be the apple, and then that one has to be the mix. So that also sorts it out. So in this case, we only need two. But let's say we pulled out an orange. Again, let's see what it could be mislabeled as. Let's say it's mislabeled as a mix. That means it has to be the orange bag. And that means it has to be the orange bag, right? If it was mislabeled the apple bag, okay. In this game, it seems like you need the third one also. Oh, wait, actually, no. So if this one's labeled mix, then we know the third bag is incorrectly labeled the apple's bag. And if I pull out an orange, it can't be that. So this one is the apple's bag. Okay, so even that one's two. If it's mislabeled the apple one, I know the third one's mislabeled the mixed one. So this one's the mixed one. This one's the mixed, and this one's the orange and the apple. Okay, so I think you just need two. Is there any way you can do it with just one though? Let's say I pull out an apple and it says it's mislabeled as an orange. It can be mixed. It can also be apple. You don't know. Yeah, so I think it's two. I think you need two. Oh wait. Using one single pick. Hold on. Let me see. I'm just skipping the explanation. Okay, yeah. I have like a feeling I have to look at that case. But okay, let's analyze that case, right? Let's say it's just orange. Let's say I don't know the. Okay. Can I just get an eraser, man? All right, bro. What is this dog shit? All right. Let's say I'll just draw it again. Whatever. So let's say I pull it out and it turns out to be an apple. I think apples, orange is symmetrical. Without loss of generality, assume you get an apple. Let's say it can only be mislabeled as, yeah, so it can be mislabeled as anything, right? Let's say it's mislabeled as an orange bag. That means of the other two, so that means it's either mix or complete apple, right? And that would also mean that the other two are orange. The other two have to be orange. Hold up. Yeah, the other two have to be orange or mix, orange and mix, or orange and apples. I don't see how I can do that. Okay, let's say it's mislabeled as a. Okay, let's do like an easier case. Let's say it's mislabeled as an apple bag. It has to be mixed, right? And I have two other ones. How? I swear I need like. If you pick a fruit from the bag with the orange label and it's an apple, then the bag is either all apples or a mix. If you pick a fruit from the bag with the apple label, oh wait, you can choose which label to pick out of, or like choose which incorrectly labeled one it's. I think that's a thing. So let's say I have 3 bags. I think that's a better way to approach it. I know I took a hint, but I think that's fine. Mix orange, apples, right? If I willingly look into the mislabeled mix bag and it turns out to be an apple, I know that that's the true apple one. And then I know what's left is the mix and the oranges. So, and I know the oranges are between these two. So the oranges would have to be the one with labeled that, and oh, okay, so I pick out of the mixed bag. Yeah, okay, that makes sense. Yeah, I mean, if it's an orange, then I know this has to be the orange bag. That means one of these are mixed and one of these are the apple one. The apple can't be this one because that's correctly labeled, so the apple is this one. A sultan has captured 50 wise men. He has a glass currently standing bottom down. Every minute he calls one of the wise men who can choose either to turn it over, upside down, or bottom down, or to do nothing. The wise men will be called randomly, possibly for an infinite number of times. When someone called to the sultan correctly states that all wise men have already been called to the sultan at least once, everyone goes free. Wait, what? Hold on. But if his statement is wrong, the sultan puts everyone to death. Okay. The wise men are allowed to communicate only once before they get imprisoned into separate rooms. Design the strategy that lets the wise men go free. Okay. Interesting. It's just flip a. Okay. Interesting. Oh, okay, okay. So what is going to indicate? Hmm. Interesting. So what's going to indicate like the count? I was thinking like a binary number sort of thing, but like I don't know how people can track it because it's just one thing. What if he makes it so that like if someone has if okay, so it's like the strategy would be like if someone there'll have to be one guy to keep track of like what's going on, but like for the others, if they have hmm. So each of the 49 people. So if they have been called up already, do they leave the glass as it is? How do I don't know. I look, I don't know. Yeah. Should flip the guy. Okay, wait. Here's one of such strategies. Okay. Every one of the 49 wise men should flip the glass upside down the first time that he sees the glass bottom down. He does nothing if the glass is already upside down or he has flipped the glass once. The spokesman should flip the glass bottom down each time he sees the glass upside down. And he should do nothing if the glass is already bottom down. After he does the 49th flip, which means all the other 49 wise men have been called, he can declare that all the wise men have been called. Wait, what? Glass upside down. Flip the glass bottom down each time he sees the glass upside down. Each time he sees the glass upside down, he should do nothing if it's already bottom down. Okay. Oh, okay, because it goes infinite time, so uh, he only has to flip it. Okay, so he only flips it when because the other people don't mess with it if it's. Oh, I see. So someone will not touch it if it's already bottom down, and they will not touch it if it was like it's the first time seeing that it's bottom down. Yeah, okay, that makes sense. All right. Oh, whoops. Okay. Okay. Wait, so what's this section called? Wait, I know I'm like silent, but like I don't give a shit. Alright. A clock numbered 1 through 12 fell off the clock and broken into 3 pieces. You find that the sums of the numbers of each piece are equal. What are the numbers on each of the piece? So each of the piece is what is that? 78 divided by 3, 26. Is it 26? 78 divided by 3, yeah, 26. 3 different pieces. So like one has to be in one of them, right? So 2 numbers summing up to, interesting, okay. No, wait, pieces. No strange shape. Do they mean like piece from the okay, I don't know. I'm assuming they meant piece from like the center and it's like perfectly shaped or whatever. I feel like 1, 12, 11 and does that work? 1 and 2. Yeah, that's perfectly 26. That's clearly 1. Another one would be like 10, 9. Ah, shit, never mind. That doesn't work because 10 plus 9, 19 plus 8 is 27. And then, but 26 I can only get if it's, bro, no, I don't know what strange pieces means, bro. Like, what is strange piece, bro? Like, all right, like what about 3, 4, 5? That's 12. 6, 18. 7, that's 25. So clearly it's not 1. So what if it's like 12, 1, 2? Because 12 has to be, I don't know if my recording stopped, but like, whatever. Like, because clearly 12 has to be somewhere. So 12, 1, 2, 3, that's 18, 22, and 27. Okay, that doesn't work either. What do you mean by like strange? Wait, what do you mean by strange piece? I'm trying to see. Okay, did they not explain strange piece anywhere? I don't know. Seems like 12, 11, 1, 2 have to be the thing, because like if not, 12 can't be away from 11 because it's just not possible to get 26. And then so 12 has to be with 11, so it has to have 1 and has to. So 1, 12, 11, 2, or 12, whatever, 11, 12, 1, 2 is one group for sure. Now though, I do have 3, 4, 5, 6, 7, 8, 9, 10. What do you mean by irregular? What about like 5, 6, that's 11. Like 5, 6, 7, and wait, 26. Like 3, 6, 10, 7 works. But like I don't know what like irregular shape bullshit. 10, yeah. I get like 25 and 27. So -1 +1. What about 987? 987 is 987 is hold up. Shouldn't that be shouldn't 9873 work? No, it doesn't. Yeah, I don't know. Like what do you like I don't know what they mean by some bullshit. Hold up. What? 3, 4, 9, and 10. But that's still like irregular. Right. I don't know. Because that still doesn't make sense cuz like I have two numbers here, two numbers here. It's like a half broken disc here and half. How's that regular? Bro, what? Okay, whatever. I mean, I did get the 12-1 part. I mean, that's the free part. So, um, 5, 6, 11, 18. Oh, I also summed that up wrong. Okay, yeah, whatever. Suppose we have 98 distinct integers from 1 to 100. What is a good way to find the two missing integers? Um, two missing. So it's like 50-50 minus uh mm, I'm assuming I can just sum it up, right? Because that would just mean okay, I can. Okay, so assuming you can someday 98 up, and that's easy. Wouldn't it just be easier to like count? This is stupid. This is actually a stupid question. I was gonna say, okay, some like 50-50 is the sum of the first 100 numbers, then subtract the sum of this, and then you get x plus y, and then sum of n. Yeah, like that is all like sunshine and rainbows. But like if you can sum up all those numbers, you can also keep track of what numbers you got. It's O of n either way. It's actually probably easier to just go through them and find out. Pretty badly phrased question. If they said you knew the sum or something, sure. But even then, it would be sum of z squared. Yeah, this is pretty bad. Okay, let's see. There are 10 bags with 100 identical coins in each bag. In all bags but one, each coin weighs 10 grams. However, all the coins in the counterfeit bag weigh either 9 or 11 grams. Okay, can you find the counterfeit bag in only one weighing using a digital scale that tells the exact weight? Alright. I feel like you take some coins out of the counterfeit bag and Okay, I low-key just read the solution. No, I'm not gonna lie. Yeah, okay, I low-key read the solution, but I just got tempted. I just read it. Oh my god, okay. Because I had like a really stupid idea of just like, hey, what if I just take one coin from like each bag and put it into like one single bag or something and sum all of it up. And I just wanted to check if that was like the right thing, but like, shit. Okay. Let's see. Is this all the problems? Okay, this one I think I can just do without looking at the problem. Okay. You're holding two glass balls in a 100-story building. If a ball is thrown out of the window, it will not break if the floor number is less than X. And it will always break if the floor number is greater than or equal to X. Okay. You'd like to determine X. What is the strategy that will minimize the number of drops for the worst case scenario? Okay. Whoops. What am I doing? Okay. 100-story building. And okay. So let's say I drop it first from the first floor. That's actually the least ROI. Well, I was thinking, okay, with like binary search, you do log 100 base 2, and I'm assuming you like the ceiling of it. So that would be like 7, right? Can we do better than 7? Let's see. So like let's say you drop it from let's say the 50th floor. Yeah, I mean that's just binary search again. And let's say it breaks, then you know it's less. Oh wait, I only have 2 glass balls though. That's the problem. Oh, okay. So I can't really do that, can I? Let me see. Wait, I'm just looking at the problem part. The floor number is great. What is the minimum number of okay. Okay. Let's say I start with 1, then I go to like 3 because 1 plus 2 is 3. Then let's say I go to 6. Let's say it breaks at 6. That means it must be either 4 or 5. So I'll go for 4. You're holding. Wait, do I care if my last ball drops? Hold on. Okay, yeah, then you need 2 more. What is the minimum or the worst case scenario? Let's say it's like, let's say it is 100, right? Like here, let's say in this 136 example. Okay, so I'm trying to be the best for like worst case scenario, right? Let's say I do like 1, 3, 6. Then the next one is 10. Next one is 15. Then I have 21, 28. But why am I doing that? Like, let's say 21 works. Why can't I just keep doubling? I don't know. I do think it's, I don't know. I thought it was like, it would just be 7. I thought binary search would be the best, but like, or let's say I do like, oh yeah, I forgot it's because like I do, so let's say I do 1, if it doesn't work, I double it. 2, if that doesn't work, I do 4. 8, let's say it breaks at 8, but doesn't break at 4. I'll go from 5, 6, 7, like I have 3 in between. Worst case scenario would be like 64, and then it breaks at 100, obviously. But let's say I make it to 64. I would anticipate that it obviously breaks at 100. Actually, I can't do that. Let's say interesting. I have no idea as well. Let's see. Okay, for the first throw of ball 1, we can try the nth floor. If the ball breaks, then we try to start the second from the first floor and increase until there are n minus 1 floors to test. So maximum of n throws are enough. We have n minus 1 throws left. This time we can only increase the floor number by n minus 1 for the first ball. Oh, I see. Interesting. That's pretty good. Yup. Okay, that makes sense. Oh, that's pretty good. That's pretty good. So you set it with n, whatever the optimal is. Okay. Pigeonhole principle. I don't like this shit. Division by 9. Okay. Chameleon colors. Huh. Let's see. Then there's induction. I don't like any of these topics, I'm not gonna lie. Proof by contradiction. Okay, I don't want to do any of this, I'm not gonna lie. Okay. But you know, whatever. I'll do as much as I feel like it. I've only done 6 of these pages. I do have to. No, you know what? I'm gonna complete this. I'm gonna have to do it at some point or the other, so I might as well do it now. All right, we'll see. So, okay. Your drawer contains 2 red socks, 20 yellow socks, 31 blue. Oh, sorry. 21. Oh, what am I saying? Yellow socks and. Okay. What is the minimum number of socks you need to guarantee? So it's 1 plus 19, 20 plus 30, 50. Oh wait, sorry. Oh wait, no, I'm tripping. I thought I misread it. I thought it was guaranteed that you get all the socks of one color. Even then, actually, I think the answer would not be. Okay, no. But yeah, it would be 4. Yeah. Okay. Oh my god, I got hiccups, bruh. Oh, alright, you're invited to a welcome party. I'm just gonna read it in my mind. $25 people. Okay, since a number of people. Interesting. Okay, if you don't know the total number of handshakes, can you say exactly with certainty that there are at least 2 people who shook hands with exactly the same number of people? I don't know. I mean, okay, so everyone will be shaking hands with like anywhere from 0 to 25 other people. Let's say there's like 5 people, right? Each person shakes hands with either 0 people, 1 person, 2 people, 3 people, or 4 people, right? And so if 0 exists, then 4 can exist. So then it would just be like then it would be 0, 1, 2, or 3 people. So you have these 4 things, and there's 5 people. So yeah, I think that's the pigeonhole thing. There are 26 people at the party, and each shakes hands with from 1, since everyone shakes hands, to 25 people. Okay, each of them do. Yeah, so it is 1 through. Okay, yeah. Makes sense. Okay. Show me that if there are 6 people at a party, then either at least 3 people met each other before the party, or at least 3 people were strangers before the party. Okay. Or at least 3 people were strangers. I mean, isn't this just like obvious? I don't know. And then, like, let's say one person, or let's say 2 people met each other before the party. That means 4 people were, and then let's say it has to be an even number for every, right? Or let's say 3 people met each other before the party, then that already satisfies the case. Let's say 0 people met each other, then I mean, I don't know. In each case, it's like, yeah, I don't, wait, what? Show me that if there are 6 people at a party, then either at least 3 people met each other before the party. Like, I don't know, case 1 where like they none of them have met each other, then they were strangers, and all 6 were. If one, it doesn't make sense for one of them to. Let's say 2 of them met each other before the party, then the other 4 were. If isn't it just case by case, and I don't know. That sounds like some bullshit. There are 51 ants on a square with side length 1. If you have a glass of radius 1/7, can you put your glass at a position on the square to guarantee that the glass encompasses at least 3 ants? Okay. If you have a glass of radius 1/7, just some numbers I'm looking at are like 51, 3. That means 17, and I see 7 for whatever reason. But I also know 7 times 7, 49. 51 minus 49 is 2. That's like less than that. So I don't know. Those are just some numbers immediately that are popping up. 51 ants on a square with side length of 1. Okay. And its radius is 1/7. So like, oh, they're on the square, as in like, are they in the square or on it? And what is the length of each ant? Because like, if all the ants are like on the exact same point, pretty much, what does that like prove? I don't know. I'm so confused. 3 ants. I was assuming like you divide 51 into like, yeah, I guess, yeah, it would be 25 or 25.5 or something. Or no. Uh 25 times 2. Yeah, right, yeah. You have a glass. Separate the area into 5 by 5 smaller squares. Wait, what? Simply separate the area into 5 by 5 smaller squares, okay? Each will. What? We can separate. I feel like the question's like pretty ambiguous here. We can separate the square into 25 smaller areas, which I get, but can't all of them just be on the same thing? Like, we can show that at least one of the areas must have 3 ends. Yeah, that's true. At least one of them do. So we only need to make sure that the glass is large enough to cover any of the 25 smaller areas. No, because if the glass just covers the one square, like the few squares that don't even have it, that doesn't prove anything. What? Simply separate the area into 5 by 5 smaller squares with side length 1/5. Okay, which you already did when you split it into 25 smaller areas. Simply with side 1/5 each will do, since a circle with 1/7 can cover a square. What? I don't know. I don't believe in that problem either. There are 5 bags with 100 coins in each bag. A coin can weigh 9 grams, 10 grams, or 11 grams. Each bag contains coins of equal weight, but we don't know what type of coins a bag contains. You have a digital scale. How many times do you need to use the scale to determine which type of coin each bag contains? Okay. I don't know what type of, okay. I mean, okay, the brute force is just do 5, right? Just like weigh it 5 times and then boom. But okay, as per the pigeonhole principle thing, because that's the whole topic, we have 3 different selections, but we have 5 bags. So at least 2 bags will be like repeat. Yeah, like 2 bags will be like repeat weights. So like the 5 bags, like at least 2 of them will be. You have a how many times do you need to use a scale to determine which type of coin each bag contains? Okay. Like, so it's either gonna weigh 900, 1,000, or 1,100, right? And there's gonna be 2 more bags that like weigh some like weird amount. Can like, do I know that? Okay, so here's the thing. I don't know if like it's necessary for each bag to have one of these types of like things. Let's say that's the case where we know that it has to be. Then okay, I don't know. I don't know how pigeon. It seems like some long ass answer. Okay. Well, I'm not gonna read the answer, so like I'm not gonna like see it. But I think I might low-key call it here and switch over to some programming, because this is just pretty boring. Actually, I do have other things I do gotta like get to, so I might call it here and do some programming later. But yeah, we will see what happens. Yeah, okay, I don't feel like doing any of these. I am tired of these brain teasers, low key. Okay, I've done like, I know the last few were sloppy, but like I was actually locked in on the first few, so I did like 20 pages, I guess. How many problems did I actually do? Let's see. I'm not counting like this counterfeit one or this ants on the square one. But that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, 27 problems. I'll take that. Oh, whoops. I guess I'm still recording. But yeah, I'll take that. Yeah, I think that's about it. I'm gonna see what happens. So yeah, I wonder if I've always been recording only like that proportion, or if I should have been recording a bigger one. Whatever. Anyways, peace.